All right, let's take a look and kind of recap what we've looked at in the past couple of topics and really lay out our approach whenever we evaluate the limit of rational functions. So let's just go ahead and take an arbitrary rational function, which we'll say is f of x equal to g of x divided by h of x. In other words, it's a rational function. We have something in the numerator, something in the denominator. And let's say that we want to evaluate the limit as x approaches a of this particular function f of x. Well, if we evaluate using direct substitution f of a, we can interpret those results for the limit as x approaches a of f of x. In other words, if you kind of read this sentence backwards here, if I want to know what the limit as x approaches a of f of x is, in topic 1.5 we discussed how we can use direct substitution, looking at f of a as our first chance to really evaluate this limit. And so we're going to get one of three results when we do this. And the first one is if f of a is a real number, which we'll call c. In other words, if I substitute a into f of x and I get a value, 2, 1 over 4, 0, some sort of actual number value, then that means the limit as x approaches a of f of x equals f of a, which we just said was equal to c. So if we use direct substitution and get an answer, that's our answer for the evaluation of this limit. Then we looked at two other cases, and this is what we really laid out in topic 1.6. If f of a, so again, we're talking about just directly substituting a in, gives us a non-zero number divided by 0, and this is going to look something of the form, if you think about plugging a into this function, what this is implying is that g of a is not equal to 0 and h of a is equal to 0. So when I substitute a in, if I get any number besides 0 divided by 0, then what we said was that f of x has a vertical asymptote at the line x equals a, and if it has that vertical asymptote, then that means that the limit as x approaches a of f of x does not exist. So we're either going to get a real number, and that's the evaluation of our limit. We're going to get a non-zero divided by 0 answer, and that tells us there's a vertical asymptote. Or, as we spent most of topic 1.6 looking at, if f of a gives us the indeterminate form, or unindeterminate form, which again is going to look like 0 divided by 0, that does not mean the limit doesn't exist. It doesn't mean the limit equals 0. What it means is other techniques must be used to actually attempt to evaluate the limit. So we're only going to get one of three results here when we use direct substitution. We're either going to get a real number, and then that's our evaluation of the limit. We're going to get something besides 0 divided by 0, and that tells us there's a vertical asymptote and the limit doesn't exist. Or we get the indeterminate form, which means we need to go into our algebra bag of tricks to try to find a technique that might simplify the function where we can try to evaluate the limit again.